word. Yeah. Okay. So
Oh.
this is easy. No problem.
I was so concentrated on the homework here.
No problem. All right. Yeah. So this is not bad. I mean, here, I mean, you want to integrate with respect to u. I mean, this is constant, of course, so there'll be just u power 6 over 6, and then you integrate with respect to v. The integral of v e to the v square would be just half e to the v square, right? I mean, you can use a substitution or yeah. Anyway, I mean, integral of this. Is okay. So I guess this answers your question, Anicia.
Yes.
Okay, perfect. Do you guys have another question about the homeworks? Homework number 3 or any homework? I mean,
number 6. That one.
Number
Spherical
6.
coordinates.
Number
Yeah, I
6.
want to do one of polar coordinates as well. But this
still
one...
in homework number 3.
Yes, homework number 3.
Oh,
okay. So
But
you were saying
David has
problem
one.
6.
Yeah, I didn't
So what's the problem? Okay.
no, homework number 3 on homework number. You said number 6, Anicia, or?
Yeah,
Yeah,
number
she said
6 and
problem
homework
6.
number 2.
Yes, we can go over that one. That's spheres. Yes.
Okay, yeah, that's this. Yeah, that's the spheres because.
I want to go over spheres and polar coordinates, and I think that's it for me.
Okay, so using the question is evaluate the integral, blah blah blah, the solid bounded by the spheres using spherical coordinates. All right, so spherical coordinates. Just let me remind you, spherical coordinates. So that's x r sine of phi cosine of theta. Y is r sine of phi sine of theta, and z is r cosine of phi. And all right, so first thing to do, I guess, is to find the bounds, right, for r, phi, and theta. So I would say the first step would be to find the bounds. Step 1. So let's say you want to find the bounds in terms of r, phi, and theta. Right. So all right. So what's my solid S here? It's bounded by the spheres radius 1 and the sphere of radius 2. So if you want to sketch this solid S, that will be, so this is X, Y, and Z. So you're gonna have this first you're gonna have a ball of radius 1. So you're gonna have this ball here of radius 1. Okay, so this is supposed to be 1 here. I mean, well, my sphere is not it's not very nice, but anyways, this is supposed to be 1, etc. So it's radius 1, and then another sphere of radius 2. So you're gonna have, let's see, here's 2 somewhere. All right, that's not okay. It doesn't matter. So we have this second sphere. All right, so this is supposed to be a ball of radius 2. This is 2 here, right? So my solid is bounded by the 2 spheres. So we have these 2 balls of different radius, one of radius 1, one of radius 2, and so between the 2 spheres you have your solid S. So my solid S would be this solid here. So that will be my solid S. All right, so you want to express this in terms of, you want to find the bounds in terms of r, phi, and theta, right? So, so in general, r is supposed to be the radius. Okay, so r, this is the radius, right? This is In other words, so if you have x squared plus y squared plus z squared, they'll be equal to r squared, right? So here you have the solid between these two spheres of radius 1 and 2. So it's like saying you have, your solid S is bounded by, so your solid S is bounded by the sphere of radius 1. So x squared plus y squared plus z squared plus y squared plus z squared is between 1 and 4. Right. So this one here, when x squared plus y squared plus z squared equals to 1, that represents the sphere of radius 1. So this is the sphere of radius 1. And this 4, this means that you have a sphere, this is a sphere of radius 2. Okay. So x squared plus y squared plus z squared, that's r squared, right? I mean, that's in the spherical coordinates. And the spherical coordinates is like a polar coordinates. If you do like a polar coordinates, if you do x squared plus y squared, you get r squared, right? So this is like a three-dimensional version of polar coordinates. So if you do x squared plus y squared plus z squared, you get r squared. Okay, so r squared is between 1 and 4. So in other words, r, because r is the radius, is always positive. It's positive, or it's so it's between 1 and 2. Okay. Now, is there any other restriction on the solid S? No, that's it. I mean, it's just bounded by these two spheres. So in particular, the phi. Remember, the phi is supposed to be the angle between the positive side of the z-axis and your point. So phi here, there's no restriction on phi. So what I'm saying is that r is the radius. Now the phi is supposed to be, this is the z-axis. So if you have a point here, then phi would be the angle between the z-axis, the positive side of the z-axis, and your point. So this is the angle phi, right? So here in our region, in this solid S, the phi go from, if you have a point here, that will be, the angle here will be 0. But if you have a point here in the bottom, then this would be your angle phi, right? Anyway, so phi, it goes from 0 to pi. Okay. The same thing for theta. Theta here, there's no restriction on theta. So phi goes from is between 0 and pi. Theta is between. So if you take a look to your projection into the xy plane, into the xy plane, you have like a full circles. So there's no restriction on theta. So your theta supposed to be between 0 and 2 pi. So theta is between 0 and 2 pi. Okay. So again, remind you, what's theta? Theta is the angle. So you take the projection of your point. This is my point. You take the projection into the xy plane. This is my x. This is my y axis. You take the projection into the xy plane. And so theta is the angle between the projection and your x-axis, right? So this is, here's my projection, right? And so theta would be this angle here between the x-axis and the projection of your point into the xy plane. That's theta, right? So
Professor,
yes,
how
go
did you
ahead.
get 0 to pi?
That's by definition of phi. So in
Oh,
general,
okay.
for spherical coordinates, in general, phi is supposed to be between 0 and pi. And again, phi is supposed to be the angle between the positive side of your z-axis and your point. Like, as I said, like here, I have this point, right? So let's say this is the line going from the origin to my point, and so phi is this angle here. between the positive side of the z-axis and your point. Now, in my region or my solid S, okay, probably I should graph again my solid S. So, I mean, the idea is like you have my solid S would be like this region here, bounded by the two spheres, right? And what I'm saying is my phi, it could go from 0 to pi, because if you have a point here, then here's my phi. If you have a point here in the bottom, then here's my phi, right? So you see the phi, it goes from 0 to pi here. This is here 0, and this is pi here. And if you have a point on the other side, so if you have a point here, let's say a point here, right here, then phi would be, again, it's the angle between the z-axis and your point. So here's my phi in this case, and it's less than pi, right? So it's always between your point and the positive side of your z-axis. So by definition, your phi should be between 0 and pi. It's like saying a radius r. In general, the radius is a positive number. It could go from 0 to positive infinity, right? But now for my region, in this specific example S, the phi, there's no restriction on phi here, but because you, all the points here in this annulus, right? The angle phi would go from 0 to pi, okay? And the same here for theta. Theta is by definition, theta is supposed to be between 0 and 2 pi, okay? But if you check your solid S here, there's no restriction on theta, because if you take the projection into the XY plane, right, you have some region here, okay, so this is, let's say, the projection here into the XY plane. So your angle theta would go from, and this is supposed to be x-axis, y, and z. So your angle theta is, I mean, you're going to go from, this is like 0, and you can cover the whole circle here, go back to here, and that will be 2 pi. Okay. I mean, what I'm gonna say, yeah, well, I don't know if there's another example of spherical coordinates in the review sheet, but I mean, anyway, so in this example, I mean, this problem, you would have, so the conclusion in this example, for this particular example, are between 1 and 2, phi, there's no restriction on phi, and phi by definition, it goes from 0 to pi. Theta, the same, it's by definition, it goes from 0 to pi, and there's no restriction on theta for this specific example. Okay, there's only restriction on r, right? You need your radius to be between 1 and 2. If you have like a different solid, let's say, if you change a little bit this problem and you say, well, this solid S is between the two spheres, and let's say it's just in the first first quadrant, or you know, let's say you add another restriction, right? So then you have to check, you have to be careful with the phi and theta. You have to check if your phi or theta are they are there just from 0 to pi or 0 to pi over 2. Well, it depends on the problem. Okay, so anyway, so for this, for this example here, we'd have 1 over, so square root of x squared plus y squared plus z squared, that's square root of r squared. Okay, and then don't forget the Jacobian. The Jacobian for spherical coordinates is r squared sine of phi. So this is the Jacobian for the spherical coordinates, and then spherical coordinates, and then of course you have the r, let's say d phi d theta. And I mean, 1 over r square root of r square, that will be 1 over r. So that's r square over r. So that'll be just r sine of phi, dr d phi d theta. R is between 1 and 2, phi between 0 and pi, and theta between 0 and 2 pi. Okay, and this is not really hard to integrate again. David, does this answer your question, Anisi? I mean, I hope it's more
Yes.
clear now. David, you said that you had a trouble with the problem number 3, or right? Problem number polar coordinates, right?
Yes, I want to just review the polar coordinates, make sure I'm doing it correctly. I mean,
and
we
which
do
problem?
homework
Problem 3?
number 3. I think it was 3,
4.
right?
Well, there are 2 about the polar coordinates. There's the problem 3 and 4.
3. It'll be 3.
Okay.
But
Works.
3 is fine.
3
3
is
is
fine.
okay. Let's do a 4, please.
Okay. Problem 4.
Good.
This is again homework B. Problem 4. Right. Let's see. So we have this 0, 2. You have 0 square root of 4 minus x squared, square root of 1 plus x squared plus y squared dy dx. Okay, I think for polar coordinates, I mean, we know the Jacobian. So the main thing here is I would say the main problem here is to find the bounds, right? So that's I would say that's the main thing here. So I would say step 1 is to find the bounds in terms of r and theta. All right, so let's see. You know, x is between 0 and 2, and y is between 0 and square root of 4 minus x squared. I mean, you don't have to do it, but you can sketch, if you wanna, you can sketch this region, the corresponding region here. It's just, so x is, let me just sketch it for you here. So if you wanna sketch the region here. So this is my x, y axis. So we are saying x is between 0 and 2, right? So my x, this is 2 somewhere here. So my x is, this is x is equal to 0, and this is x is equal to 2. All right, and then y is between 0. So this is here, this is y is equal to 0. And then there is this y equals to square root of 4 minus x squared. Of course, that means that y squared is 4 minus x squared. And in other words, x squared plus y squared is equal to 4. So this is just a circle of radius 2. So we have this circle here of radius 2. All right. So anyway, so my region is between the 2 green lines, x equal to 0, x equal to 2, and then y equals to 0, and the circle. So that'll be the first quadrant of my disk. So the region D would be this region here. This is my region D. Okay, it's between the x equal to 0, x equal to 2, and it's above the x-axis because y is larger than 0, y is positive, and under the below the circle, right? So it's the first quadrant of my circle. Anyway, so now in terms of r and theta, the radius r. So here, if you have a point, you can imagine if you have a point here inside your region D, so then the radius, that's the distance from the origin to the point, right? So your radius r is just between, it's inside this disk of radius 2. So R is between 0 and 2. So R is between 0 and 2. Okay, because it's just because you're inside or in the interior of the circle of radius 2, right? So the radius is just between 0 and 2. Now, the angle theta, here you have to be careful because we are just in the first, our region D corresponds to the first quadrant, right? So if you have your angle theta is supposed to go from, from 0 to 2 pi, but then for this first quadrant, theta is just from 0 to pi over 2. Right, this is my theta here, right? So theta is just from, it's not the whole, it's not from 0 to 2 pi, it's not the whole circle, it's just the first quadrant. So that's from 0 to pi over 2. And then, so that's for the bounds. Is there any question about the bounds? So I mean, it helps to sketch the region, but it's not necessary to sketch the region. But still, it helps, and you can see it just from the graph that your angle theta is actually just from 0 to pi over 2. Okay, but I mean, you can also use the equations if you want. I mean, it's just. But I think I prefer, like in the 4 polar coordinates. I think I would probably sketch the region, but because it would help. Anyway, so then my integral would be, so square root of 1 plus x squared plus y squared. So that will be square root of 1 plus r squared dy dx. So the Jacobian for the polar coordinates would be r. This is the Jacobian polar coordinates, dr d theta, and then r from 0 to 2, theta from 0 to pi over 2. And I think this is not really hard to integrate because you have the derivative of r squared outside. You can use a substitution here. You can say, for example, u is equal to 1 plus r squared. So then, du is just 2r dr, and so you're gonna have so this double integral square root of u, and then r dr, that would be r dr, that would be half of du. Right, so we're gonna have half here and du, and that is d theta. Right, and then integral of square root of u is just so that'll be equal to half. So this would be so integral of square root of u. We have to integrate with respect to u using this substitution, right? So that'll be u to the power 3 over 2 over 3 over 2. Okay, d theta. But then u is equal to this one. So then u is equal to, just here, write it down for you. So this is half. So you flip the 3 over 2, that would be 2/3. So this is times 2/3 here, and this would be 1 plus u is 1 plus r squared to the power 3 over 2. Okay, and this is evaluated. So r is from 0 to 2, right? R is from 0 to 2. Theta is from 0 to pi over 2 here. This is d theta. All right, this is all I'm saying here, guys, is that u is equal to 1 plus r squared. And then, and then I guess it's not, you have just to evaluate r equals to 2, and then r equals to 0, etc., etc. And then it's easy actually to compute here. All right, so I hope it makes sense to you, David. I don't know, is there any other question about this, David? I mean, does it make sense to you? Well, I hope so. All right. Is there any other question, guys? I think there's also another polar coordinates in the review sheet, problem in the review sheet. But anyway, is there any specific request, guys? About any question about the homeworks?
No.
No. All right. So
Go to
I
the review
guess.
sheet now.
Okay, yeah, so I guess I can go over the review sheet. Well, I mean, there are a lot of problems in the review sheet. There are like 10 problems. I mean, I guess I cannot, I won't be able to do all the problems in just 1 hour or 1 hour and a half or 1 hour and 15 minutes. But so I'm gonna try to pick like some problems, but let me start from with the problem one. Change the order of integration. I mean, there are two different integrals here, changing the order of integration. I can do one of them. Let's do one of them. So this is a review sheet. All right, so let's do, I don't know, there's a e to the x cube and there's a sine of x squared. But anyway, in both problems, so this is problem number one. Anyway, in both integrals, you need to change the order of integration. Okay, so otherwise you're gonna be in trouble. If you want to just integrate with respect to x, I mean e to the x cube. That's actually very hard to. I mean, it's actually you have to use some approximation to integrate the e to the x cube, and the same for sine of x squared. So anyway, so the goal is of course is to change the order of integration. So let's do the first one, e to the x cube. Okay, so the goal is of course to change the order of integration. So first step would be like whenever you want to change the order of integration. So the first and the most important step is to find the new bounds. So, step one. So here we have find the bounds with respect to. So here we have in the problem, it's the dx and then dy. So we have to change the order to dy dx. Dy dx. Well, so I would say first thing to do is just to sketch, I would say, sketch the region. So you know that your x, let's start with y. So you know that your y is between 0 and 1, and x is between square root of y and 1. Okay, so if you want to sketch this region D, well then x, this is y. So first you have y equals to 0. That's the first equation, right? You have y equals to 0. So this is y equals to 0. And then you have the second equation is y equals to 1. So this is y equals to 1. So this is 1 here. So this is the line. This is a horizontal line, y equals to 1. And then third equation is you have x or square root of y is equal to x. So if you take the square, then x is y squared. So this is sort of parabola, but in along the x-axis. So if you wanna graph this x equals to y squared, then that will be this parabola. So let's say this is x is equal to 1 here, and let's say here's 4 somewhere, here's 2. Okay, of course, if x is equal to y, or y is equal, sorry, if y is equal to 0, x would be 0. So this is so you have, so if y is equal to 0, let me just change the color here. I'm going to use the blue, I guess. Okay, so I was saying, so if y is equal to 0, for example, x is equal to 0. If y is equal to 1, x would be equal to 1. If y is equal to 2, for example, x would be equal to 4, etc. So, and if y is equal to -1, x is equal to +1, etc. So it will be this point here. Y is equal to -2, x will be equal to +4. So we're gonna have this. This is the parabola. So, oh, sorry. This is sorry. It's x squared equals to y. I wrote here. Sorry. This is x squared. What did I? Yeah, it's no, sorry. It's x squared equal to y, not my bad here. So that would be, this is x equal to y squared. Sorry, it's my bad. So y is equal to x squared, of course. This way here. All right, so then that will be this parabola here. And I have this parabola here. All right, sorry. So this is y equals to x squared. All right. And then we have x equals to 1. So the other equation is x equal to 1 here. So here's x equal to 1. This is x is equal to 1. All right. And then so my region D would be this this region here. So this is my region D. All right. Anyway, guys, so okay, so that's my region D. Anyway, so we're gonna change the order of integration, right? So then, so first you need to start with, so here, you start with y between two constant, right? We are saying y is between 0 and 1, right? You have, this is my y equals to 0 here. This is y equals to 1 here. And then my x is between this parabola here. This is y equals to x squared. And this is x equal to 1. This is x equal to square root of y. All right. Now, I'm going to start with x. So x between two constant. X between constant. Okay. So then my x would be between here. So this point here, this is x equal to, this is the x coordinate here is x equal to 0. The x coordinate here is x equal to 1. So my x would be between 0 and 1. All right. and then y. Okay, and then y would be between this. So here in the bottom, this is y equals to 0, and this graph here, and this graph is just y equals to x squared. So y between 0 and x squared. Okay. Okay, so then, so that's the new bounds with respect to dy dx. So then my integral, so then this is step number 2. Step number 2. So we're gonna have, so now it's e to the x cube, right? But now it's dy dx. Okay, so we are saying y is between 0 and x squared, and x is between 0 and 1. Okay. Now, of course, now if you integrate with respect to y, x would be constant. So this thing here is just a constant. Okay, this is just a constant. So, so the integral of that would be just y times the constant. So it's equal to, so here's 0, 1. So it's y times the constant, and y between 0 x squared. So this is my dx. So then if y is equal to x squared, so this is 0, 1. So it's x squared e to the x cube, and then minus 0 dx. And now this is actually easy to integrate. I mean, you can use a substitution if you want. So this is we can use a substitution. So u is equal to x cube. Then du would be 3dx, 3x squared dx. And so so then we're gonna have, this integral here. So e to the, so x cube is equal to u. So this is e to the u, and then this x squared dx, the x squared dx, that will be du over 3, right? So this is du over 3. Well, integral of e to the u with respect to u is just e to the u, right? And there's a constant, there's division by divided by p, so that's just a constant. So it's just e to the u over 3, right? But then in terms of x, u is equal to x cubed, right? So that's e to the x cubed over 3. And your x is between 0 and 1. So if x is 1, that's e to the 1 cube. So that's e to the power 1. So it's just number e over 3. And when x is 0, e to the 0, that's 1. So minus 1/3. Anyway, guys, so the point here, of course, is the first step here. The first step, just be careful. I would suggest to, like, in this, like when you have like just 2 variables, I mean, I think it's probably a good idea to sketch your region D. You want to switch, interchange the order of integration, right? So then here your y is between 2 constants, and then x between these 2 functions. So when you switch, or you want to interchange the order of integration, then your x should be between 2 constants, and then y between 2 functions, right? So which is our case here, right? X between 2 constants, and then y between 2 functions. Is there any question, guys, about this problem 1? I mean, how do we change the order of integration? As I said, the best idea would be just sketch the region, and just be careful also. I mean, you have to be careful. Sometimes it's not obvious, but anyway, let's see. So yes,
For
Anissa.
number 2, can you find the bounds? I want to know if I got it
Yeah,
right.
just the bounds. Okay, Yeah, I can
Once
find them.
once you
Yes.
get the bones, not the
Yeah,
bone,
then,
all you gotta
yeah.
do is calculate. So
Yeah. So let's try to find the bounds for number 2. Okay, so this is again the review sheet.
that's the one with the triangle.
Yeah, triangle, yeah. All right, so step 1, find the bounds in terms of well, X and Y. So let's see. So we have this triangle vertices. So we have 0, 0. So this is okay. This is my x-axis, of course. This is y-axis. I'm gonna need 3. Okay, 1, 2, 3. Okay, so 0, 0. Let's say this is 0, 0. And then I'm gonna need 1, 3. 1, 3. Let's say it's somewhere here. Let's say this is 1, 3. Probably I should use a 3. This is 3. This is 1. And I'm going to need 2, 2. Okay, so 2, 2. So let's say this is 1, 2, 2, 2, right? Somewhere here. Okay, I mean, my units are not perfect, but I guess you get the picture here. This is 2, 2. So here's 0.22. And so my triangle would be this one here. Oops. All right. So we need to find the bound. So the main problem here, guys, actually, I would say is to find the equation of the lines. I mean, the sides here of the triangle, you have 3 sides, obviously, right? And the problem is really just to find the equation of the lines, right? So first line, so let's call this first side here, this is side number 1. Let's call this side here side number 2, and this is my side number 3. Okay, for the first side, this is line going from passing through 0, 0 and 1, 3, right? So line 1. So this is passes through 0, 0 and 1, 3, right? So then, the equation of a line is of the form. So in general, the equation of a line is of the form y equals to ax plus b, right? A is the slope. I guess you know this. A is the slope. All right, so let's say this is x1 here, y1, and this is x2, this is y2. So A, the slope would be just, y2 minus y1 over x2 minus x1. So y2 is 3, y1 is 0, x2 is 1, x0, x2 is 1, x1 is 0. I'm always thinking about the next step, So sometimes I just get confused. Anyway, so this is 3 over 1, which is a 3, of course. So the slope is 3, right? And then B, you can just take passes through, let's say, so it passes through. I'm going to just write down the details for the first line, and then the next lines, I'm going to just go very quickly, okay? It passes through, let's say, I don't know, 0, 0. So 0, 0 would satisfy the equation, right? So there'll be y is equal to 0 equals to the slope, which is 3 times x, which is 0, plus b. Okay, so then b is just 0. All right, so then the first equation is y equals to y is equal to 3x. Okay, if x is 0, y is 0. If x is 1, then y is 3, right? Line 2, same thing. I'm gonna just so line 2 would be of the form. Line 2 would be equal to, so y, I guess the slope would be so it's 2 over 2, so it's 1, passes through 0, so b is 0, so y is equal to x. Okay, so this is for line number 2. And for last side, the line number 3, the other side. Line P. So passes through. So line 2 here, this line here passes through the 0, 0 and 2, 2. Okay. For the third line passes through. Just be careful with the third line. It's the one passing through 1, 3 and 2, 2, right? So passes through 1, 3, 3 passes through 1, 3 and 2, 2. So then the slope A would be, let's say, so difference between the y's. So 2 minus 3 over difference between the x's. So it's 2 minus 1, right? So it's -1 over 1. So it's -1. That's your slope. That's -1. Your b, just pick a point. Let's say y is equal to 3 times the slope times the x. X is 1 plus the b. So then b is equal to 4. Okay, so a line p, the equation of the line p is y equals to -8, the slope -1, so it's minus x plus 4. So you want to check the answer, of course. X is 1, then y is 3. If x is 2, then y is 2. Okay, so it's correct. Now the bounds. Okay, so now, so be careful here with the bounds. All right, so we have this. This is 1, 3 here. This is 2, 2. Okay, so this is, we said y is equal to x. This is, no, so sorry, that's not line 1. We said the equation of the line 1 is y equals to 3x. Sorry, this is, this is y equals to 3x. This is the first line, right? So this is what, sorry. So this is y equals to 3x. This is y equals to x. And then we have, this is y equals to minus x plus 4. Right? I mean, this is my x-axis. Here's my y-axis. Anyway, guys, so my first question for you, is this elementary region? So because here, remember guys, elementary regions, so if you have so my question here, is this triangle, is this triangle an elementary region? So remember guys, I mean, in order to be an elementary region, so like there are like basically like two main cases, right? So either you have like two parallel horizontal lines, and then they are connected by like the graph of two functions, or you have like a point here and another horizontal line, and connected by some graph of two functions, or you could have like 2 points, one here in the top, one here in the bottom, and connected by two graphs, or you can have also two vertical lines. So for example, here, here's two vertical lines, and then connected by the graph of two functions, or you could have one vertical line and another point here connected by the graph of two functions, or you could have like 2 points here and connected by the graph of two functions, right? So here in this case, this region here, it's not actually elementary region. Actually, you have to divide it, divide this triangle into two, let's say, sub-triangles. And then the sub-triangles would be elementary regions, because you see, guys, here you don't have, you don't have neither parallel horizontal lines or nor parallel vertical lines, right? So this region is not an elementary region. So we have. So does it make sense to you guys why this is not elementary region? Because, you know, in the elementary region, like here, in this case, this is like saying here, in the first case here, this is like saying, you know, your y, this is like, let's say this is y equals to a, and this is like y is equal to b. Because when you say y is equal to some constant, then it means that you have like a horizontal line. Okay, when y is equal to constant, then it means that then it means that you have horizontal lines, right? So in elementary regions, your y or x should be between two constant, right? So if you're saying y is between two constant, then it means that y, either you have like two horizontal lines, or you have just one horizontal line and one point. So this would be y is equal to, here would be y equals to a, and this point here, the y coordinate would be y equals to b. Or here, the y coordinate would be y equals to a, and here y equals to b. Okay, and connected by graph of two functions. So this is supposed to be x, some function of y, and this is x equal to some function of y. In the second case, when you have like two parallel vertical lines, so this is like saying this is x equal to a. So when we say x is equal to constant, it means either you have like a vertical line, or you have a point. Like here in this case here, this is the x coordinate is equal to a, or in this case here, the x coordinate is equal to b, right? And this line here, this is x equal to a. Here, this is x equal to b, etc. Okay, and then the line, the vertical line is connected to the other vertical line or to the other point by you know, graph of two functions. So then the functions would be this. So this would be y equals to some function of x, f of x, and this would be like y equals to some function of x, g of x. Anyway, for this triangle, we don't have vertical lines or horizontal lines, right? So in that case, you have to divide this into so this triangle into two sub-triangles. So for example, you can say, well, I can divide this like using this line here. Okay. And so if you use this line, then this region here would be an elementary region, because now I'm connecting this point to this horizontal line here, this line here, right? So I'm connecting a point to a horizontal line. That's perfect. Makes sense. Like this would be this case here, right? Here I'm connecting like a horizontal line to a point. So here I'm connecting this point to this horizontal line. So that's an elementary region, right? Now the second region is the second subtriangle, is this one here. And this is also an elementary region, because I'm connecting this point to this horizontal line. Okay. So what's the equation of this horizontal line, for example? This is 0.22, right? The y coordinate is equal to 2. So this horizontal line, the equation of this horizontal line is just y equals to 2, right? Because the y coordinate of this point is 2. So actually this exercise is not as easy as it looks, right? Because so you need to, which one? Number 2, yes. So you need to divide actually your triangle into two subtriangles, and the two subtriangles would be elementary regions. So then, okay, so what I'm saying, guys, is that so my integral e to the x minus y dx dy over d, that will be the sum. So the integral over the first elementary region, d1, say e to the x minus y dx dy plus integral over d2 e to the x minus y dx dy. Okay, now what's d1 and d2? So where so again, this is a 0.22 here. So we have this here, this here, this here. So let's say d1 would be, so this one here, this is d1. This region here, it's d1, and d2 is this, the one in the top. So the d2 would be this region here. This is d2. Okay. Now let's describe d1 and d2. So for d1, well, probably I should, why I have this very smaller triangle, I can, let's zoom in here. So let's take a bigger triangle. So let's say here, this is 2, 2 here. This is 1, 3. So what I'm saying is this is d1 here.
Professor,
Yes.
I have a question. If we use the other point, would it still be correct?
The other what? Points. Which point?
If we use the, what's the point of there?
Your
To connect to the bottom to y equals x, would it still be,
like this.
yeah, would that
Yeah,
be correct?
that's also correct. Yes, that's another way to divide this region into elementary regions. Because yeah, absolutely, you're correct. Because in that case, you're connecting this point to this vertical line, right? And the second region here, you're connecting again this vertical line to this point. So yeah, so absolutely, that's another way to do it. And so what's the equation of this line in that case? So this is a 0.13, right? So because we have a vertical line, so it's x equal to some constant. So it's passing through the 0.13. X coordinate is 1, so that's x equal to 1. So that's another way to divide the region into, yeah, absolutely right. Yeah, another way to divide this region into 2 elementary regions. I mean, if it's up to you. You want me to do the bounds for with the x equal to 1? I mean,
you can just continue.
I mean,
then we can move on to a different question.
Okay. And then I don't know if you have trouble with do you think you're gonna have trouble with finding the bounds for these 2 sub-triangles? I mean, like
I found the bounds doing it the other way.
okay, let me just do it as you did. So let me just let me just do it as you did. So let's say d1, this is 1 p here. So let's say d1, this is line here. So this is d1 here, and d2 is here. Okay, so for d1, so this is x is equal to 1 here. This is x is equal to 1. This line here, right? This is line x equal to 1. So this is 0, 0, of course. So you can say, so d1 is, so d1 can be described. So your x, you can start with x if you want. X would be between these 2 constant, 0 and 1, right? You have this 0 here, and this is x equal to 1, right? This is x equal to 1 here, and this is x equal to 0. And you connect them using these 2 functions. This one here in the bottom. So the one here in the bottom, this is y equals to x. And the one here in the top, this is y equals to 3x. Okay, so then y would be between, in the bottom it's x, and in the top is 3x. So it's between x and 3x. And then the d2, so d2, so we have this line x equal to 1, and it goes to this point 2, 2, right? This is 2, 2, so x here is equal to 2. And you are connecting these 2, the segment to the point using these two functions here. So there's one here on the bottom. This is y, still the same, y equals to x, but the one in the top, this one here, this is y equals to minus x plus 4. Okay, so you can say, well, your x is between, so here, this is x equal to 1. This is x equal to 1. So x is between 1 and 2, and y between x and minus x plus 4. Okay.
Yeah, okay. That's
Did you get these bounds?
Yes. So
Okay,
does this happen with every triangle?
No, it depends. So for example, you could have like a, like a triangle. I don't know. Let's say you have this triangle. This one here, yeah, let's say here's a point. So this is, let's say 4. Say this is 4, 1, for example, and this is 0, 0. Okay, so this is 4, 0, for example. Here, you see, you have a horizontal side here. This side here, it's a horizontal side, right? It's, horizontal line, right? So you are connecting this horizontal side or this horizontal line to this point. Okay, so this is an elementary region. This is elementary.
Yeah.
You don't need to divide. Or you can have, for example, you can have like a triangle with some vertical side. So for example, you have, let's say you have this triangle here. Let's say this one here. Okay, this is another triangle, and this is also elementary. You don't need to divide it because you are connecting this, you see this vertical line to this point. So that's an elementary region. So it depends on the triangle.
So for number 3, what would be the bounds?
For number 3,
Mhm.
in the review sheet,
Yes.
let's see. Number 3. Oh, well, the integral is not, it's not really obvious there. But yeah, for the bounds, so this is problem number 3. So it says the D, I can sketch the region D, but it says y between half and the 1, and then x squared plus y squared less than 1. So that's a circle. So you have x squared plus y squared less than 1. So if you want to sketch this region, then that will be, so let's sketch the region here. As I said, I think in the two-dimensional case, if you have just 2 variables, it will be a good idea to sketch the region, because it's not hard in general. If you have just two
Would we
variables.
be able to use polar coordinates for this one, or you want us to stick to x and y?
You can use polar coordinates, but I think the goal of this exercise is not really to use the polar coordinates. In theory, like when I read this problem here, you're not. I would say the goal is not to use the polar coordinates, but of course you can use them. Yeah, because whenever you have like equation of a circle, that's a good point, because whenever you have like equation of a circle, the region like looks like a part of a circle, a disc or a circle, then yeah, that would be a good idea. But I think it's not, you can do it even without polar coordinates. But let me just sketch the region here. So, you have y between half, let's say this is half here, this is y-axis. So this is 1. So we are saying y between half and 1. So this is half, y equals to half. This is y equals to 1. And then you have this disk, x squared plus y squared less than 1. This is the disk of radius 1, of course. It's the inside of the circle of radius 1. This one, so you have this circle, radius 1. This is radius 1. But then, so the region, your region D would be the one between y equals to half and y equals to 1. So this is your region D. This is supposed to be your region D. Okay. So my question here would be: is this an elementary region? The answer is yes, because you see you're connecting, there's a point here in the top and there's a horizontal line here in the bottom here. Okay, so you're connecting this horizontal line. I mean, this is y equals to half, of course, to this point where the y coordinate is equal to 1. So y is between half and 1. And then what about x? Well, x is between the graph of these two functions. You know, you have this function here. This is the first function, and you have the second function on the right side. I'm going to use black, let's say here. So this is here. Okay, so this is, I mean, there's obviously the equation is x squared plus y squared equals to 1. Like interested in x, right? So here, the x, well, it will be negative, right? The x coordinate on the second quadrant, the x coordinate is negative. So here x is minus square root of 1 minus y squared. Now on the first quadrant, x is positive. So this is x is equal to plus square root of 1 minus y squared. So I would say, so the bounds, so if you want to write this in terms of the bounds, so you're going to have half here, 1 here, you're going to have minus square root of 1 minus y squared and plus square root of 1 minus y squared. And then you have this y cube, x squared plus y squared, let's see, and negative 3/2, and then dx dy. Right. Now, how do we integrate such thing? Well, I would say here it's probably better to change the order of integration, or use the polar coordinates. Okay, so if you change the order of integration, then well, so then your y would be between, okay, yeah, y is between half and 1. Now x, so if you change, of course here you're gonna integrate with respect to x, but you have this x squared, right? And outside x squared, you don't have like an x, right? So if you try to use a substitution here, you're gonna be in trouble, sort of. So I would say you can go with the polar coordinates, or you can just change the order of integration. Let me show you, for example, when you change the order of integration, how it works. So now, if you change the order of integration, then your x, you start with x. So x is supposed to be between two constants now, right? So for this region here, x would be, so you have this point here, you see this point, and there's this point here. Okay, so you have a point here, a point here. Okay, so you have to find the x coordinate of this point and the x coordinate of this point. And then you're going to connect these 2 points using the graph of 2 functions. So here in the bottom, this is y equals to half. And here in the top, this is the equation of the circle. So this is y equals to plus, because y is positive in the top, 1 minus x squared. Now, what's the x coordinate of this point? I mean, y is equal to half, right? So y is equal to half, and it belongs to the circle, right? So y is equal to half. And so x is just a square root, or minus, because here x is negative, minus, 1 minus y squared. So that's minus square root of 1 minus half square. Right, so that's 1 square, 1/2, a half square, that's 1/4. 1 minus 1/4, that's 3/4. So that'll be square root of 3/2. So this is minus square root of 3/2. So the x coordinate of this point, you see why y is equal to half, because I mean, here, this is the line y equals to half, right? This point here, the y coordinate is equal to half, right? And it belongs to the circle, so it satisfies the equation of the circle, right? So then x is minus square root of 3/2 here. And the other side would be just the positive square root of 3/2. Okay, and then the y coordinate is just between the bottom, it's y equals to half, and the top is just the equation of the circle. That's plus square root of 1 minus x squared. Anyway, my point is, if you change the order of integration, then still you have this y cube, x squared, y squared, negative 3/2, dy dx, x between square root of minus square root of 3/2 and positive square root of 3/2, and y between half and plus this square root of 1 minus x squared. Well, this is, I would say this is easier to integrate than the original integral, because there's this y cube outside, so we will help with the integral, and actually I think it's just you have just to use the integration by parts here, because if you use integration by parts, so we're going to integrate with respect to y now, right? Integration by parts. Okay, so because you have this y square, so outside y square you need y, but here you have y cube, right? So I'm gonna write this y cube as y times y square, right? So anyway, so what I'm saying here, guys, is that you can say, well, u is equal to y squared, and v prime is equal to y times x squared plus y squared to the power negative 3/2. U is y squared, u prime. Of course, we are integrating with respect to y, right? We don't really care about x. X is just constant. So y squared derivative is 2y, and then this is v prime. So the integral of this, because you have this y outside, you can use a substitution if you want, but this would be just probably, let's see, so it's x squared plus y squared. So you're going to integrate, so you're going to have negative half. And if you, now what about the constant? So you're going to need, let's see, you're going to need what? So negative half, so it's, and then 2y, that's negative 1. So I think you're going to need just minus, if I'm not mistaken. Okay, that's the integral. But anyway, so if you integrate by parts, so you're gonna have u times v minus integral of u prime times v, and then u prime times v is just u prime is just 2y, and v is minus x squared plus y squared and negative half. But then again, we know how to integrate this because you have y square here, there's a y here, so the integral is just up to constant, it would be just x squared plus y squared to the positive 1/2 to the power positive 1/2, right? And so this is easy to integrate. All right, so anyway, so all I'm saying, guys, here, of course, there are different ways, as David suggests, you can also try the polar coordinates, because well, you have the region D is part of a disk. So if you use the polar coordinates, you just be careful with so the radius. You have to be careful with the radius r and the angle theta. So for example, your angle theta, it goes from this point here to this point here, right? So theta is between these two angles, right? So what's this angle here, for example? Well, this is the point we said it's this is the point. I mean, this point here is square root of 3/2 and a half, right? Right. So, so what would be that angle? You have the point square root of 3/2 and half. So what would be the angle? I mean, x is supposed to be the cosine of the angle, right? This x, this is cosine of theta. and half, this is supposed to be the sine of theta. Right, so then that will be just 30 degrees. So this is the angle. So then theta, if you use polar coordinates, then theta is between 30 degrees. This is pi over 6. And the other point here, this is the point, minus square root of 3 over 2 and 1/2. So this is just the other side. So then that will be pi minus, or 180 minus the 30 degrees. So that will be just 5 pi over 6. Okay, so again, I'm saying if you use polar coordinates, just be careful with the angle theta, because in this case, for my region D, the angle theta is just, it's supposed to be between this pi over 6 and 5 pi over 6, okay? All right, guys. Do you have any, okay, let's see, next.
We check the bounds for number 4 and 5.
Yeah, sure. So for number 4, okay, now the 3 variables, in the space, I mean, it's in general, it's very hard to, I mean, it's not obvious to sketch the region. So, this is again, the review sheet. The problem number 4. All right. So we have x equal to 0, y equals to 0, z equals to 0, etc. Okay, so if you want to try, I mean, just to give you like a rough idea about this region S, or solid S. So a rough idea would be, so if you want to sketch S, the solid S, right? So this is X, Y, Z. So X is equal to Z, the plane X equal to Z, Y equals to Z, Z equals to, X equal to 0, Y equals to 0, and Z equals to 0. X equal to 0, that's like the YZ plane, the plane which contains the Y and the Z axis. Y equals to 0, that's the XZ plane. The plane that contains the X and Z axis, and then Z is equal to 0, that's the XY plane. All right. Now, then you have X plus Y equals to 1. So what's X plus Y equals to 1? That's the equation of, it's not the equation of a line. So just be careful, because we are in the space. We have 3 coordinates. Okay. X plus Y equals to 1. That's an equation of a plane, not a line, not just a line, right? X plus Y equals to 1. So this equation is true for any height Z, right? So it's like saying, if you want to sketch this, sketch this plane, so this is a plane, equation of a plane. Okay, so for example, when the height Z is 0, so when Z, for example, is 0, you're gonna get the line X plus Y equals to 1. So you're gonna get the Y plus X equals to 1. So that will be this line here. Okay, I mean this line. Okay, so you're gonna, when the height Z is 0, you're gonna get this line. Okay, but then of course this equation is true for any height Z. So which means that you can go along the Z axis here, or the bottom here. All right, so that will be the plane X plus Y equals to 1. Okay, So it's like saying when z is 0, you have this line, y equals to 1 minus x, or x plus y is equal to 1. And then you have to go like, you go like parallel along the z axis, because that equation is true for any height z. So you're gonna get this this blue plane. And then there is another equation, which is z equals to x plus y. Now, z equals to x plus y, of course, that's the equation of another plane. So z is equal to x plus y. That's an equation of a plane. So for example, when equation of a plane. For example, when z is 0, when z is 0, you're gonna get a line x plus y equals to 0. So in other words, y is equal to minus x. So y equals to minus x. So for example, x is 0, y would be 0. So we're gonna have this line here. And then x is 1, y is -1. Okay, so we're gonna have, let's say, this point here. So let's say you're gonna have this. So this is y equals to minus x. So here, if you use the three-dimensional space, you're gonna get this line when z is equal to 0. But then you're gonna have some plane here. Anyway, it's gonna intersect probably the blue plane. But anyway, I know it's a mess, but I'm sorry. I'm just trying to sketch this region. So this is z equals to x plus 1. Anyway, in terms of the bounds, okay, so let's come back to the bounds here. So you can start by fixing. So first step, I would say just fix step 1. I would say try to fix, let's say, z. Okay, I mean, again, you can fix any coordinate you want, but I mean, let's just fix in this case z. It's just a random choice here. I mean, I'm not fix z first. So let's see what equations involve z. So we have z equals to 0, right? And then we have z equals to x plus y, right? So z is between 0 and x plus y, right? Because you have these two equations, z equals to 0, and that's the xy plane, and then you have this z equals to x plus y, right? So then your z is between these two equations, right? Now, once you fix z, once you fix one of the coordinate, then you have to take the projection. So step 2, you have to project your solid into the xy plane, because I fixed z. So we have to project s into xy plane. Okay, because I fixed z in the first step, because z is fixed. Z is fixed. Sorry, I'm not saying fix z here. I'm not saying here it should fix x and y. I mean fix x and y, and to find the bounds of z. Sorry. So here, fix x and y to find the bounds for z. Okay. Okay, so once you fix x and y, then your z is between these two equations. Then now projection into the xy plane. So what do you have? So what will be the region when you project your solid into the xy plane? Well, you see, guys, here. So into the xy plane. So we have, you see, you have this, when z is 0, you have y plus x. So let me just write it down here. So when z is 0, you know, where is it? So we have x plus y equals to 1, and x plus y equals to z. So this equation here becomes, because z is 0, becomes x plus y equals to 0, right? Because my z is 0. So we are in the xy plane, right? Anyway, guys, so you want to find this region here. So let's see. We have these two lines here. So we have x plus y equals to 1. So that's y equals to 1 minus x. So this is x-axis, y-axis. So you have this line here. All right, so this is y equals to 1 minus x. Okay. And then we have x plus y equals to 0. So y is equal to minus x. And we'll also have x equal to 0 and y equals to 0, right? We have x equals to 0. We have y equals to 0. We have x plus y equals to 1. And then x plus y equals to 0, because z is 0, becomes x plus y equals to 0. So x equals to 0, of course, would be this line here. This is x equal to 0. Y equals to 0 would be this one here. Okay. And then what else? So we have also x plus y equals to 0. So it's just y equals to minus x. So it will be this line here. Y equals to minus x. So it will be this line here. Will be this line here. Y equals to minus x. All right. Anyway, so the region actually, our projection into the xy plane, it's between all these lines. So it would be this. It will be this region here. This is x equals to 0, y equals to 0, and this line here. Okay, so it's just this line here. Okay, so in other words, you can say, well, for example, if we start with y, you can say y is between 0 and 1, and x is between, x is between, for example, 0 and, let's say this is x equals to 1 minus y. So x is between 0 and 1 minus y, for example. Okay. So I've just described this triangle here, right?
Okay, got it.
Mm-hmm. So in general, what you do, guys, you fix first step, you fix, let's say x and y. So it means you have to find z, right? Just write down the equations of z. So you have z equals to 0, and there's this z equals to x plus y, right? So that will be the bounds, z equals to 0, and z the x plus y. Now, second step, you have to project your solid into the xy plane. So it means that because I fixed x and y in the first step, I got my z. So in the step 2, you take this projection into the xy plane. So the z must be 0 in the xy plane, which means that you take your equations and your z becomes 0. You change, you substitute z by 0. I have x equal to 0, I have y equals to 0, I have this x plus y equals to 1, and then this x plus y equals to z would be x plus y equals to 0. And then you have just to graph these equations, and then you have to find the bounds, of course. All right. The
Can we do
volume, of
9 really
course.
quickly?
Excuse me.
Number 9 on the review sheet.
Number nine. What is it? Yeah. Well, spherical coordinates. Well, this is just okay. So number 9. Very quickly. Spherical coordinates. I mean, you know the spherical coordinates. I guess the problem with your problem is with the bounds, right? So
Yes, just the bounds, everything.
There's just the bounds. So this is, I mean, the number 9 is just the unit ball, the inside of the unit ball. So it's just the inside of the sphere. Okay, so it's just the inside of the sphere. So you have only one equation, right? It's x squared plus y squared plus z squared less or equal to 1. That's the only equation you have, right?
0
Then
to 2
x
pi.
squared, excuse me?
0 to 2 pi for most of the
Oh,
bounds,
yeah,
I
yeah,
think.
yeah. First, x squared plus y squared plus z squared, that's just r squared less than 1. So then r is 1. And of course, r is less than 1. Oops. R is less than 1 is, of course, r is positive. So r is between 0 and 1. And then that's the only equation we have. So there's no restriction on theta and phi. So theta by definition is always between 0 and 2 pi. And phi by definition is always between 0 and 5. Okay. So you have only one equation in terms of r. And then there's no restriction on theta and phi. So you're good. It's just your theta would be between 0 and 2 pi and phi between 0 and pi.
Thank you.
Any other question, guys? We have 2 minutes. Let's see. All right. I guess number 5. It's just the same solid. Let's see. So it's you see like number 5. Like number 5. I guess probably that's just in 2 minutes or I don't know, 1 minute. So like for number 5. So if you do you see you have you can start with the z. So you fix x and y. Fix x and y. You need to find z, right? Find z. Again, you don't have to sketch your solid. You can just take the equations. You have x squared plus 2y squared equals to 2. There's no z there, right? So I don't care about it for the moment. And then you have z equals to 0. And you have this x, plus y plus 2z equals to 2, right? So then if you solve for z, of course, that will be half, I guess, 2 minus x minus y, all right? So I would go first by saying that z is between this 0, like saying z between 0 and half 2 minus x minus y, right? Now, once you have the bounds for z, then you can move to the x, y. So you project into the xy plane, and so what happens for the xy plane? Well, we have this equation x squared plus 2y squared equals to 2, right? You have this x squared plus 2y squared equals to 2. I mean, this is sort of like well, I mean, it's not exactly a circle. It's like an ellipse here, right? Sort of. It's not exactly the equation of a circle, so you're gonna have like sort of ellipse here. I don't know. For example, if y is 0, x would be square root of 2. If x is 0, y would be equal to 1, for example, or minus plus or minus 1. Anyway, so this is x squared plus 2y squared equals to 2. All right. Then all you have to do, guys, is just try to find the bounds for this. I would say, for example, this is a minus square root of 2. This is negative 1, of course. And then, for example, you can say, for example, y is between negative 1 and positive 1. And then x is just, you solve for x. It's just what? Minus square root of 2 minus 2y squared, or plus square root of 2 minus 2y squared. Okay. So, yeah. All right, guys. Anyway, I'm gonna probably stop here. But yeah, I mean, of course, in 2 hours we cannot really solve all the problems. So I'm gonna wish you then good luck on Thursday. Again, I'm gonna post the test at 10 a.m. Exactly at 10 a.m. on Blackboard, and then you have until 12:15 to submit your answers. Okay, guys. If you have any trouble to submit your answers, please email me. Okay, you have to let me know if you have to submit late your answers. Let me know, okay? Because otherwise, I won't accept any late answers. All right?
Thank you,
Professor,
Professor.
Yes.
can I stay about like 5 minutes after class?
Oh
to
yeah, yeah,
ask you
sure.
something. Okay.
Yeah, yeah, sure, sure, sure. All right. So I'm probably gonna stop recording, and David, I guess I wish you good luck on Thursday. Let's just stop recording here.